This is the video supplement for the midterm of Psych 268R, Cognitive Robotics. We will be demoing our robot, named Mousebot, which was constructed using the LEGO Mindstorm EV3 kit. Mousebot was designed with the Bratenberg value-based vehicles in mind, and, as such, was modeled to perform the functions of a secondary consumer in a typical environment. Secondary consumers both hunt small prey animals and are hunted by larger predatory animals, and as such need to constantly evaluate their environment. To this effect, Mousebot has 2 sound sensors and 1 ultrasonic sensor, as well as 2 wheel motors and 1 arm motor. The sound sensors detect sound stimuli from the environment and localize their signal to spatially identify where objects in the environment may be, while the ultrasonic sensor assesses the size of any objects found that are emitting sound. The wheel motors allow Mousebot to move around in the environment, while the arm motor allows the ultrasonic sensor a range of movement so that it can more accurately assess size.
The environment that we will be using to showcase Mousebot's behavior has simple requirements. It must be flat, as Mousebot has no way to ascend or descend the environment, and it must have some devices capable of constantly emitting sounds. For this demo, we place speakers which constantly emit pure tones to optimize Mousebot's performance.
Mousebot begins by constantly moving forward at a slow pace when no sound is present. When sound is introduced, Mousebot begins to move slightly more rapidly in the direction of the sound via the difference in received signal between both sound sensors. After either sound sensor reaches a certain threshold of sound, Mousebot will stop and turn in place to more effectively localize the sound input until both sensors receive an equal amount of signal. When the sound has been localized, Mousebot will take a low ultrasonic reading, raise its arm, take a high ultrasonic reading, and then lower its arm. Based on these ultrasonic readings, Mousebot will perform one of 3 actions.
If neither ultrasonic reading results in the detection of a close stimulus, Mousebot will appear confused, turn to a random direction away from the signal, and move away. After this, Mousebot will automatically begin its behavior again in the hopes of finding a stronger signal with a stimuli attached. If only the low ultrasonic reading results in the detection of a close stimulus, Mousebot will celebrate as it believes it has found either a food source or a smaller creature that it can kill and eat. After celebrating, Mousebot eats its prey and then ends its search behavior. If the high ultrasonic reading results in the detection of a close stimulus, with or without the low ultrasonic reading, Mousebot will cry and run away from the stimulus as it believes it has found a predator that is larger than it is, and it will revert to self-preservation. As it is scared, it will also end its search behavior.
Besides reacting to a number of different values, Mousebot is biologically valid in that it has several features which closely model human behavior. Only 1 ultrasonic sensor is used to replicate the 1 pair of eyes that humans have, and Mousebot must raise and lower its eyes to scan the environment in the same fashion that humans must move their heads to look above or below them. Also of note is that the ultrasonic sensors localize sound in a very similar way to how the human auditory system works. In humans, auditory localization is partially conducted by computing the interaural amplitude level difference of 2 different sounds. This computation allows us to localize the source of sounds in a given plane around us. Similarly, Mousebot performs this computation by constantly sampling from both microphones and taking the difference between the signals that both microphones are receiving. A stronger response on one side of Mousebot will prompt it to turn in the direction of the stronger signal, which should result in Mousebot moving to more accurately find the source of the sound signal.